Good evening, everyone. Welcome to another Planetarium live stream. Welcome. Thanks for joining us on this lovely Friday evening. A bit of a change of pace for our streams. We're going to let some folks gather around. Let's check in and see. Got some viewers today. Welcome. All right, excellent. We've got a bit of a crowd gathering. Welcome, everyone. My name is Patrick Hess. I'm the Planetarium Manager at Union Station, and I'm excited to see you here for our, 86th live stream. And thank you to our supporting sponsor, MRI Global, for keeping these programs going, as well as many other programs at Union Station. And welcome, everybody. This is going to be a stream that'll last about an hour long, hopefully, and we're going to be touching on what's up in our night skies over the course of the next month, looking at stars and constellations, doing a little star tour, and we're also going to check out what's up in the past, over the past month, looking at different news updates of what's been going on around the world of astronomy and space exploration. A lot of stuff to cover today. Also, since this is a Friday live stream, we switched things up a little bit this month. We'd encourage you all to put in your comments and questions. We always welcome everybody's comments, questions, and we love to hear where you're watching from, so leave us a comment saying where you're watching from. But in the spirit of Fan Fridays, which is our live stream we used to do a couple of years ago when we first started these in 2020, I'd encourage you all to ask any question you could possibly think of about space and astronomy. We're going to try to keep things really active and interactive in the comment section tonight. So any questions you have about any of the topics we cover, please throw them in. And if you have just a question about life, feel free to post that too. I give great advice. We do have a couple of housekeeping tidbits to go over. So as everyone is continuing together, we're going to check out what's going on around the planetarium for this month. So stay tuned for that. Also, just FYI, we do have recordings of all of our past 85 live streams on our YouTube channel. That's youtube.com/KCPlanetarium. So be sure to head over there at some point tonight and like and subscribe. And you can find recordings of these and past streams there too. So what's going on around the planetarium and Union Station this month? Well, we are closed right now. Every year in September we close for a couple weeks since things are kind of slow. Everybody's going back to school. And from the 6th through the 16th, that's this week and next week, we will be closed to the public, doing a little maintenance and training, nothing out of the ordinary, but Science City is closed as well. So we'll be back open next Saturday for public shows, and we do have an exciting lineup for you this fall. You can see there, I'll duck down a little bit, or I can just do this, I guess. So we do have a fun program coming this fall, starting on the 17th, and this will be up to Thanksgiving. So check it out. We've got a couple returning favorites: Magic Treehouse, Space Mission, a great kids show, as well as our new shows for the summer: Destination Solar System and Legend of the Enchanted Reef. As always, Sky Station Live is our live seasonal star tour. And returning back to our lineup is one of our fan favorites, Dinosaurs at Dusk, The Origins of Flight. A fun show going back in time looking at not just dinosaurs, but flying dinosaurs, as well as the evolution of feathers. It's a great show, one of the favorites of our audiences. So if you like dinosaurs, check that out for sure. Let's keep things going here. We've got that is not right. I'm just going to change this now. October, and this is live. October 1st. There we go. You all didn't see that. So October 1st, the first Saturday of October, we're doing our next set of evening laser shows, and that's going to be British Invasion. For the month of October, we've got a great lineup featuring the Beatles, Rolling Stones, Bowie, Elton John, and Queen. Tickets are on sale now for those, and laser shows do often sell out. We had a couple sold out shows for September's showings, which were Arena Rock Legends. And don't worry, for all you Pink Floyd fans out there, we'll have more Pink Floyd shows for you sometime soon. So get your tickets now. Again, those do sell out. That'll be the first Saturday of October, featuring artists from across the pond. We're already getting a couple people commenting in the comment section. Don't forget, this is a live stream. If you're watching on Friday, September 9th on 2022 at 6 p.m. Central. This is live. Hello, I'm Patrick, and I'd love to see your comments. We already have Letty saying thank you for sharing. Thanks for watching, Letty. If you have any questions, let us know tonight. Tony is asking who is here. Who's here, Tony? Tony's here. Patrick is here as well. Anybody else who's here, be sure to shout us out in the comments. We've got Tori saying thank you for sharing this. Thanks for watching tonight. And Jerry saying hello, watching from Kansas City. Jerry, so glad you're tuning in tonight. I know you've been excited for tonight's stream, and even if it's just you asking the questions and commenting, then I'll still be happy. So Jerry, throw those questions my way if you can. Back to our news segment about what's going on around the planetarium. Here's a fun announcement. Tickets should be on sale soon for a special edition of Sky Station Live. On September 17th, that's next Saturday at 5 p.m. after our last public show of the day, we'll have a special members-only extended star tour. Our star tour typically lasts about 30 to 40 minutes, but this one, you'll hear me blather on for over an hour most likely, and we will be looking at our regular star tour stops, plus a lot of other planets and moons we don't normally see during our star tour, and as a special treat to celebrate the opening of the Maya exhibition. There we go. I can't think of the word. We are going to be looking at Mayan skies. That actually should say Maya skies. Here's a fun vocab tip for you. It's Maya. You only say Mayan when you're referring to the language. Patrick, we need to get that graphic updated. You got it, Patrick. All right. So anyway, like I said, next Saturday we're going to be doing a special members-only showing of Sky Station Live. So you can get your tickets pretty soon, hopefully by the end of the weekend. And it'll be a fun extended edition of the Star Tour featuring different constellations, astronomy, and cosmology from Maya culture. So check that out. Also, an upcoming telescope viewing opportunity the Saturday after that, or the Friday after that, is going to be a members-only Jupiter opposition viewing event. We'll be looking at Jupiter and Saturn, actually, but these planets will be at their closest approach to Earth, and so it should be a spectacular viewing event. You'll be able to see the rings of Saturn in addition to the moons of Jupiter, the clouds on Jupiter, maybe even Jupiter's great red spot if we're lucky. So that'll be starting at about 8 p.m. on that Friday night. And this is for Union Station members only, so if you're curious about Union Station membership, this is one of the many great benefits that we offer, including free tickets to the planetarium and free admission year-round to Science City. So check that out. Also, the exhibition Maya, which is all about Maya culture, is now finally open at Union Station after a few delays over the summertime. It is open to the public. And here's another fun tidbit. This is one of our highest rated exhibitions in 20 years. And I'm not just blowing smoke, that is based on actual data that I've seen. So it should be really amazing, and hopefully you'd love it. Tickets start at around $14, and we do offer deep discounts for EBT card holders. So check that out now. Again, Maya, the exhibition, is open to the public. All right, so let's get into tonight's Star Tour content. What's up? What's going on in our fall night skies, as well as what's gone on in current events over the past month. A bunch of great updates for you. So stay tuned for those, and keep the comments coming. This is a live stream, and I'd love to hear your comments. So if you have any comments, be sure to throw those in, like Jerry, who's asking us, for those of us new to the planetarium, who is Arvin Gottlieb? Jerry, that is a great question. And Arvin Gottlieb is a person who has given a lot of charitable donations to many of the people of Kansas City, and I'll be totally honest, I don't actually know a lot about the life of the man Arvin Gottlieb, but I know that he cared a lot about astronomy education, as well as preservation of Union Station. And he also funded a lot of Union Station's renovations in the late 90s. But you know, Jerry, that's a great question, and one that I'd love to touch on in sometime in the near future. That would be great to do a feature more about his life and his contributions to Kansas City. So, Jerry, I wish I could answer that question more thoroughly, but that is something for the future for sure. Christy's commenting, saying, so glad I found this. Well, Christy, we're so glad you're here. I'm glad you're going to be joining us tonight. If you have any questions, let us know. And don't forget to subscribe to us on our YouTube channel, youtube.com/KCPlanetarium, for more of these live streams if you're a first-time watcher. And Megan says, can't wait to check it out. The Maya exhibition Megan's talking about, absolutely, Megan, and it is pretty amazing, so you are not going to be disappointed. All right, so let's take a tour of our fall night skies. Let's bop on over to Stellarium, a lovely piece of software I'd like to use, sort of like a flat virtual planetarium. We are looking at the lovely Kansas City skyline here on the steps of the Liberty Memorial in downtown Kansas City. The sun is setting over in the west. We have passed the summer solstice, the longest day of the year, and the days have been getting shorter. Unfortunately, we will be closely approaching the fall equinox, which is the day where the day and night is the exact same length, 12 hours. And then fall will officially start as the nights become longer than the days. That'll be at the end of this month, around September 21st, 22nd. In the meantime, those days still longer than night, so we're going to head on over tonight by fast-forwarding time here. Right now, the sun is setting at around 7:30 to 7 o'clock as the month progresses. And at about 8:30 or 9, you'll get a nice view of the night sky. And here we are looking at our Kansas City night sky. I do love the Kansas City skyline, but every time we do, unfortunately, have to switch to a flatter skyline so the buildings don't obstruct our view. Now, this view you're seeing here will not be a view you'll see in downtown Kansas City, but luckily here in the Midwest, you don't need to travel far to get away from light pollution. Light pollution comes from man-made light sources like buildings, streetlights, and car headlights. Extra light that shines up into the sky and bounces off the atmosphere, and it makes the sky kind of glow when you're near civilization. But here in the Midwest, if you get about an hour away from town, you'll find a much better view of the stars. And we're looking at that view now, and we're going to be checking out a few things that are going to be prominent in our fall night skies. We're actually going to start over in the southern sky, where as fall approaches, you'll be seeing a few constellations setting in the southwest sky. We have this big hook-shaped constellation right here. This is the tail of the Scorpion constellation. This red star is the Scorpion's heart, and its claws go out here in this sort of fan of 4 stars. And let's see if we can't get that constellation pattern up there. There we go. There it is. So this is the constellation Scorpius. Scorpius is a constellation. It's one of the zodiac constellations, 12 constellations that circle our celestial sphere and line up with the path of the sun. They're prominent in astrology, which is different than astronomy. We actually cover that in depth during our live star tour, so if you want to learn more about that, I encourage you to come by the planetarium. But Scorpius, the fun thing I want to tell you about this one is that this hook shape here in Polynesian cultures was seen as the hook of the demigod Maui, and the movie Moana actually features this star pattern pretty accurately. In fact, it was a navigation tool for ocean explorers. Another fun thing you'll see in the early evening in the fall is a little teapot shape right around here. You can see the teapot's handle and the lid and spout. This is part of the constellation Sagittarius, the centaur. This constellation pops up in Greek mythology as a figure sent down by the gods to help the Argonauts on their quest for the Golden Fleece. It can be seen in the south here in the fall. Its constellation, its name means archer, and you can kind of see a bow and him pulling a bowstring back. But again, the teapot shape right around here is a bit easier to spot. Now, you'll see here in our view of the night sky, our virtual view, that the stars are twinkling near the horizon. Stars twinkle because they're very far away from Earth, and by the time a distant star's light reaches our planet, only a tiny amount of it is able to pass through the Earth's dense atmosphere, and our atmosphere causes that little speck of light to wobble and twinkle. But not everything you'll see in the night sky this season is going to be twinkling. There are a couple bright points of light that will be rising in the southeast. After sunset, you'll see them around the moon tonight. And these points of light, this one here and this one down here, you'll see are not twinkling. And these are objects that are much closer than distant stars, so close that their light appears in our night sky as a full disk, which means they're not disrupted by our night sky. And we can see in the constellation Capricorn there the planet Saturn, as well as the planet Jupiter. So again, look for these bright points of light that are not twinkling in our night sky, and those are the planets Saturn and Jupiter. Now, Jupiter, as I said earlier, is going to be reaching opposition at its closest approach in a couple weeks. And Saturn had its opposition about a month ago, so these two planets are very, very beautiful to look at in our night sky. are through even a moderately powerful telescope, you can see them resolved in pretty great detail. Now we can zoom in on the moon tonight. The moon looks like it is just about full, but it's not quite a full moon. Let's see. The full moon is actually going to be tomorrow night. But tonight is actually a great time to observe the moon because right before a full moon and right after a full moon, the moon actually, although it's not full, has a lot of shadows still on its surface, and those shadows are what reveal its details. The night of a full moon, the moon is the sun is shining directly on the moon, so there aren't a lot of shadows on the surface of the moon, so you actually can't see much of its details on a full moon. So right before a full moon is a great time to observe the moon. Let's actually look a little bit higher overhead. Over in the southeast sky, actually directly overhead here, you'll find a bright triangle that appears overhead, and was a little turned around. There's the triangle. These three bright stars, some of the brightest stars in our summer skies, form the summer triangle. And this is a star pattern that can be used to track the changing seasons. As fall approaches, it'll be seen directly overhead after sunset. The brightest star in the summer triangle is this star up here, called Vega. It's the fifth brightest star in the night sky. And it's part of a constellation called Lyra the Harp, which represented a harp that belonged to Orpheus, a famous poet and prophet. Inside of the Harp constellation, though, is a deep space object called the Ring Nebula. Now, the Ring Nebula is what's called a planetary nebula. It actually has nothing to do with planets, but it contains the remnants of a dead star. So when average-sized stars die, they'll slowly expand, shedding their outer layers one at a time, leaving behind these rings of colored gas. Now, the Ring Nebula here, this image was taken by a space telescope that's a few decades old, but we've actually taken pictures of another planetary nebula similar to the Ring Nebula using a more recent telescope that was sent to space. You may have heard of it, the James Webb Space Telescope. So I actually wanted to highlight how that imagery has changed and gotten better over the years. So actually, let's bring Stellarium back. So this is a picture, again, of a planetary nebula using imagery from before the Webb telescope's time. But these are pictures taken by the James Webb Space Telescope of another ring nebula called the Southern Ring Nebula. And you can see that that imagery is quite a bit better than the images we had before. If you've missed it, the Webb Space Telescope is a brand new space telescope that launched at the beginning of this year, actually the end of last year, and was just recently deployed a couple months ago, and we've just started to get images from the Webb telescope. And you'll want to stay tuned for this stream tonight, because we'll be looking at some other data that Webb has provided since its launch, so stay tuned for that for sure. All right. We've got Jeannie in the comments saying, this is great. Well, you're great, Jeannie. Thanks so much for watching. And let's keep the comments coming, everybody. I love hearing everybody's comments. So if anybody's watching, if anybody's there, then let us know. Let us know where you're watching from, too. And if you have any questions about tonight's stream, let me know. We're going to dive right into our first news topic of the day, and that is the Artemis 1 mission. So I wanted to provide an update about the Artemis mission, NASA's current sort of big mission to the moon. And so we've got Artemis's website pulled up here. But just to give you a little summary about what Artemis is, the Artemis program is NASA's plan to return to the moon. Basically, for the first time in over 50 years, we would like to set foot on the moon again and send the first woman and the first person of color to the moon, using innovative technologies to explore more of the lunar surface than ever before. They're collaborating with commercial and international partners to establish the first long-term presence on the moon as well. So you might wonder why we're going to the moon. NASA's got an answer for you. We're going back for scientific discovery, economic benefits, and of course, inspiration for a new generation of explorers. Ask anybody who was around during the Apollo program, and you can tell them that people were just excited about science and innovation during those times. So there's a really good reason to go back to the moon right there. It's just getting excited about making new things and expanding our technology, and it'll benefit us all. If you're curious about why we are going to the moon or why we even go to space, we actually did a whole live stream way back on Thanksgiving of 2020, and that was on November 23rd. That was our 49th live stream, fun fact. You can find a recording of that on our YouTube channel, youtube.com/KCPlanetarium, where we did a deep dive that day into why we're thankful for space exploration, looking at NASA's spin-off technologies, new developments and inventions that came from space exploration, and other important innovations. There are some cancer research projects being done on the International Space Station, for example, that can only be done in microgravity. So there are a lot of good reasons to go to space and a lot of good reasons why we want to go back to the moon. Now, in terms of the Artemis 1 mission, which is the first big mission, unfortunately, it's had a couple setbacks. So this is the first official planned space flight of NASA's Artemis program. This mission will be uncrewed, so no humans aboard, and it will be a moon orbiting mission, planning on staying around there for about a month, 25 days. Now the Artemis mission, the Artemis 1 mission, was scheduled to launch August 29th, but it was delayed due to some offshore storms, as well as some issues with one of the rocket's 4 main engines. We can go back in time on their blog here. So they had some issues. They also had some communication delays, fuel leaks, and cracks on insulating foam. So they did scrub that launch and planned on a second launch attempt on September 3rd. Unfortunately, though, the launch was scrubbed hours before liftoff due to another fuel supply leak in a service arm connecting to the engine section. So over the course of the past week, the mission operators have been investigating whether an overpressurization of the liquid hydrogen line of the quick disconnect interface during the launch attempt may have damaged a seal, allowing hydrogen to escape. The launch operators have not yet decided on a date for the next launch attempt, but NASA is preserving options for the next launch opportunity as early as Friday, September 23rd, so potentially the night of our telescope event. Stay tuned for that. Hopefully it does not get delayed again, but all things are going well. The good news is they have not had to move the spacecraft from the launch pad, which would be a much bigger delay. So hopefully we can get this next launch opportunity. You can read more about it on NASA's blog. All right, everyone, keep the comments coming. If you're watching tonight, we'd love to hear your feedback. We've got a comment from Casey, who is one of our longtime watchers I recognize. Casey says, hello, Patrick. Tuning in again today from Gladstone. I appreciate all the knowledge you share on these live streams. While I do miss the weekly streams, I make sure to set reminders now for the monthly streams so I never miss one. Keep up the great work. Live long and prosper. Right back at you, Casey. Thanks so much for watching, and I appreciate your continued support. And I appreciate you setting those reminders. We'll try to keep them on stable days, keep them on Mondays. I appreciate everyone being flexible. Switching to this Friday stream, even though I know Fridays are sort of the graveyard shift for when it comes to televised programming. I appreciate everybody being here, or at least Casey for being here, because I know Casey's watching. So thank you so much for your continued support. All right, speaking of watching, let's do our regular segment, Webb Watch. Let's check out what the James Webb Space Telescope has been up to since our last live stream on August 1st. And there are a lot of really awesome updates to share, and I want to share some of the highlights here. For example, Webb has captured stellar gymnastics in the Cartwheel Galaxy. Check out this imagery here. Let's zoom in on that. Pretty incredible stuff. So the James Webb Space Telescope has peered into the chaos of the Cartwheel Galaxy, which has revealed new details about star formation and the galaxy's central black hole. So Webb used its powerful infrared gaze to produce this detailed image of the Cartwheel Galaxy, as well as 2 smaller companion galaxies against the backdrop of many other galaxies. And this image provides a new view of how the Cartwheel Galaxy has changed over billions of years. Now, this galaxy is located about 500 million light years away from from us here on Earth in the Sculptor constellation, so it's a rare sight. It looks kind of like the wheel of a wagon, which is the result of an intense event, likely a high-speed collision between this galaxy and a smaller galaxy, which isn't visible in this image. Collisions of galactic proportions cause cascades of different smaller events between galaxies, and the Cartwheel is no exception. So this collision affected the galaxy's structure. The Cartwheel Galaxy supports 2 rings, a bright inner ring and a surrounding colorful outer ring. These 2 rings expand outward from the center of the collision like ripples in a pond after a stone is tossed into it. Because of these distinct features, astronomers call this a ring galaxy, which is a structure less common than the spiral galaxies like our Milky Way galaxy. These observations by Webb, they underscore that the Cartwheel Galaxy is in a very transitory stage, and this galaxy was presumably a normal spiral galaxy like the Milky Way before its collision, and it will continue to transform over millions of years. Webb is giving us a snapshot of the current state of the Cartwheel Galaxy, but it's also providing us insight into what could happen to other galaxies that will undergo collisions like the Milky Way, because our galaxy is on a collision course with the Andromeda Galaxy. But that will happen in about 4 billion years, so we don't exactly have to worry about it too much. Checking into the comment section, we've got James and Donna saying these are always so informative. James and Donna, thanks so much for watching. I appreciate your support as well. And Jeannie saying the imagery is stunning. Absolutely, Jeannie. Emily's watching. Hey, Emily. Emily says the Cartwheel Galaxy is very cool. Very, very cool and very pretty. Do love that picture. Thanks for watching, Em. All right, let's check out some other imagery from Webb. Here's something that was released on August 25th, a little bit more recent. And this is a bit more nerdy, a bit more charty, you could say. Oop, let's zoom out a little bit here. So check this out. NASA and the Webb team have detected carbon dioxide in an exoplanet atmosphere. So this is showing us data from the telescope, so no pictures, but still really cool information. So the Webb's telescope has captured the first clear evidence of carbon dioxide in the atmosphere of a planet outside the solar system. This observation of this gas giant planet orbiting a sun-like star about 700 light years away provides important insights into the composition and formation of this planet. This planet is called WASP-39b. Which is a different exoplanet than the other exoplanet we discovered water in the atmosphere of a couple months ago. Carbon dioxide is still very cool, though. WASP-39b is a hot gas giant with a mass roughly 1/4 that of Jupiter, about the same as Saturn, and a diameter 1.3 times that of Jupiter. It's sort of extra puffy. This is the scientific term. This extra puffiness is related to its high temperature, which is about 1600 degrees Fahrenheit. So this planet was discovered back in 2011, but our ground-based observations couldn't really see much about it. And of course, with Webb being out in space with much higher resolution imagery, we're able to actually see the different chemicals in this distant planet. So this is a transiting planet, which means it's a planet that goes in front of a star. That's how we detect these exoplanets, some exoplanets that is. And that's actually how we look at and just detect chemicals in their atmosphere. So as the planet goes in front of its parent star, the light from the star refracts through the planet's atmosphere, bending through the gases in its atmosphere. And here on Earth, or in space on the Webb's instrument panel, we can actually detect the different variations in light from that light passing through the atmosphere. And because different gases absorb different combinations of colors, researchers can analyze small differences in the brightness of this transmitted light to determine exactly what the atmosphere is made of. Understanding the composition of a planet's atmosphere is important because it tells us something about the origin of the planet and how it evolved. Scientists say that carbon dioxide molecules are sensitive tracers of the story of a planet's formation, and by measuring this carbon dioxide, we can determine how much solid versus how much gaseous material was used to form the gas giant planet. In the coming decades, as Webb's mission continues, we'll surely be making measurements of many more exoplanets, so we'll be learning even more about how planets form and about how unique our solar system is in our galaxy. Jerry is asking, when galaxies collide, is there a noticeable effect on the galaxies? Jerry, that's a great question about galaxy collision, and the answer is yes and no. So when galaxies collide, their structures will be totally obliterated. In fact, I can show you an animation using advanced computer simulations of what the Andromeda and Milky Way collision will look like. Let me pull that up. I want to do this, thanks for patience. All right, so check this out. So here is a simulation of the collision of Andromeda and the Milky Way. So our structures will be we're torn apart, basically, as the gravity of this collision crashes these galaxies into each other. But luckily, most stars are so far away from one another that there is really little chance that any two stars will crash into each other, or even solar systems being affected. But another thing you'll notice is that the color of our galaxies change. It'll start blue as the stars are younger, but it'll get more yellowish, and then eventually the structures of our galaxies will merge, and instead of being a spiral galaxy, will turn into what's called an elliptical galaxy, which is an older sort of blobby galaxy. So again, the answer was sort of yes and no. The structures of the galaxies will change a lot, but really on the micro scale, in the planets and solar systems, things won't change that much. Plus, in about 4 billion years when our galaxies collide, the sun won't even be around. It will likely have turned into a planetary nebula like the one we saw earlier. Tara is watching from the great state of Louisiana. Tara, thanks so much for tuning in. So glad you're enjoying tonight's stream. And if you want to check out any of our past streams, don't forget we do have recordings of those on our YouTube channel. All right, let's keep this Webb watch going. There's a lot of great imagery that Webb has revealed, and I want to show it to you all. And this is very cool. Here's a sort of a collaboration piece between Webb and the Hubble Space Telescope. These are new images of the Phantom Galaxy, or M74. And this showcases the power of space observatories working together in multiple wavelengths. On the left, right there, we have the Hubble Space Telescope's view of this galaxy, which ranges from the older redder stars towards the center to younger and bluer stars in the spiral arms, to the most active stellar formation in the red bubbles that you can see in Hubble's imagery as well. On the right, though, the far... Whoops. Sorry, that was my lens cap falling over. On the far right, you can see the Webb telescope's images, which is quite a bit different, strikingly so. And instead of highlighting the masses of gas and dust within the galaxy's arms, Webb's imagery highlights the dense cluster of stars at its core. You can see in blue there. And then the combined image in the center merges these two for a truly unique look at this grand design spiral galaxy, as they call it. Scientists combine data from telescopes operating across the electromagnetic spectrum to truly understand astronomical objects. In this way, data from Hubble and Webb complement each other and provide a comprehensive view of this galaxy and many others. So this is a great showcase of how the Hubble Space Telescope is still out there, still doing amazing science, and we can actually combine all of our scientific instruments to learn even more about our universe. So Hubble is still out there doing amazing science. A bit closer to us, though, is imagery of Jupiter. Here's some amazing imagery. I want to show you this one right here, actually. No, I don't want to show you that one. Let's get that back up. All right, here we go. You can see, so Webb is mostly taking pictures of deep space, but it also has a view of the outer planets in the solar system. It can't look at the inner planets, unfortunately, because Webb has very sensitive scientific instruments that require extremely low temperatures, and it has a big shield blocking the view and heat from the sun, so it can't really turn around or else it would fry its instruments. But it can look outwards, out the outer planets, and look at this imagery of Jupiter. Now, this is infrared imagery processed in a wavelength that human eyes can see. One thing, kind of as a sidebar, I want to say is that all the pictures you see of Webb are real pictures. I say quotes because a lot of people accuse astronomers and scientists of faking their images, because the Webb telescope is taking pictures in the infrared spectrum, which is a spectrum human eyes cannot see. The data that Webb is looking at and absorbing is real, though, and all that humans do here on Earth is shift that into a wavelength humans can interpret. So what you see in pictures from Webb is really light. It's light coming from these objects. It's just shifted in a way that human eyes can see. So this is a real picture of Jupiter. Specifically, it's an infrared composite image showing a bunch of different things. It's showing the auroras, the northern and southern lights on Jupiter, in much brighter detail than we can see. And it's showing the cloud structure as well. So it's basically showing us the height of the clouds using this infrared data. The lighter images are the higher clouds, the darker ones are lower. And in this wide field of view, we can actually see the rings of Jupiter, which are very, very faintly visible and not visible with the naked eye or through optical telescopes in the optical spectrum. Saturn has visible rings because its rings are composed of ice, which is highly reflective. Jupiter's rings are more dusty, though, so they're a lot fainter. But we can use infrared imagery, like imagery from Webb, to see them in much more greater detail. We can also see some of the dimmer moons of Jupiter through that imagery as well. So anyway, just kind of cool that Webb is taking pictures of stuff other than deep space. Let's move right along in our tour of what's going on in Webb. And here's some pretty amazing imagery. Webb has taken its first ever direct images, actually the first ever direct images of an exoplanet ever observed. So we've never actually taken a picture of an exoplanet. We've not had a telescope powerful enough. We've only been able to detect them by looking at their star's brightness. If a star gets dimmer when the planet gets in front of it, then we know a planet's there. But now we've actually taken a picture of the planet itself. It's a little fuzzy, but still pretty impressive. This exoplanet is a gas giant, meaning it has no rocky surface and could not be habitable. The image, which we can see through 4 different light filters, shows how Webb's powerful infrared gaze can easily capture worlds beyond our solar system, pointing the way to future observations that will reveal more information than ever before about exoplanets. One associate professor of physics and astronomy in the UK who was leading these observations said this is a transformative moment not only for Webb but for astronomy in general. This particular planet is called HIP 65426b, very, very creative name there. It's about 6 to 12 times the mass of Jupiter. The observations will help narrow that down even further as well. It's pretty young as planets go, only about 15 to 20 million years old compared to our 4.5 billion year old Earth. And this planet is about 100 times farther from its host star than Earth as well. And it's so distant that Webb was able to separate the planet from the star in this image. Emily's commenting saying, kind of jealous kids are going to get these photos in their science textbooks, and I had to grow up with those blurry 90s photos. That's true, Emily, but you know what? You get to see these pictures too, and this is an important time, or a great time to highlight how even in adulthood we can still be learning all the time and just be excited about new discoveries in space. So the kids may get to see these pictures, but we get to see them too. You know, hopefully kids seeing these pictures will ignite their excitement about astronomy, and we'll be able to explore the universe in even more better ways in our lifetimes. But yeah, I'm kind of jealous too, Emily. All right, the last picture I wanted to highlight. This one comes just days ago on September 6th, and this is an image of the Tarantula Nebula. This is a cosmic creation story unfolding. Thousands of never-before-seen young stars have been spotted in this stellar nursery captured by the Webb Space Telescope. It's nicknamed the Tarantula Nebula for the appearance of its dusty filaments in previous telescope images. The nebula has long been a favorite for astronomers studying star formation. In addition to young stars, Webb also reveals distant background galaxies, as well as the detailed structure and composition of the nebula's gas and dust. At only 161,000 light years away from the Large Magellanic Cloud galaxy, or in the Large Magellanic Cloud galaxy, this nebula is the largest and brightest star formation region in the local group. The galaxies nearest our Milky Way. So check out this Tarantula Nebula caught in NASA's Webb. NASA does love a pun. Emily says, don't let Elon Musk name that planet. He might name his 11th kid that. You know, I wouldn't put it past Elon. Elon, if you're watching, please do not name your 11th child HIP 65426b. That name is already taken. Amazing. Thank you for that, Emily. All right. So that's all of my Webb Watch highlights. And I'm just going to keep on rolling. I've got a couple... just 5 more news stories about other things besides Webb. So if anybody is still watching, I hope you enjoy the rest of the stream, but we will be wrapping up sometime in the near future. Jerry is saying, what is the bright object at the upper center? Talking about the Tarantula Nebula. Let's bring that back out here. So again, Jerry was saying the bright object in the upper center, that one right there, that is a star. And I may be able to tell you what star that is if I'm, let's see. We've got the time, why not? So let's figure out which star that is. I wonder if I can even figure that out. That's a great question. I'm not sure. I wonder if Stellarium can help us out here. Let's see. Let's search. Oh, the Tarantula Nebula is in there. Let's Tarantula Nebula. There we go. Oh, it is underground. Great, very helpful. Let's turn the ground off. All right. Okay. Now this might be kind of tricky, but we will compare. Let's see. It's the Tarantula Nebula. Looking at our image compared to. I'm not sure it's in there. It may be this star right here, which is unnamed. Very helpful. Jerry, that for the first time ever, I think that's a question that I do not know the answer to. It's a star is the answer. And most likely, though, I'll give you a bit more of an interesting answer. That is most likely a star in our galaxy, unlike the Tarantula Galaxy's location, or the Tarantula Nebula's location in the Large Magellanic Cloud. Yeah, the Tarantula Nebula is not even in Space Engine, so that's a star. But thanks for asking that question, nonetheless. I appreciate you keeping things rolling here. Kate is also keeping things rolling with a live long and prosper emoji. Live long and prosper, Kate. Thanks so much for watching tonight. All right, so here's a fun news update. We're tracking the DART mission. That is NASA's double asteroid redirection test. And the spacecraft that was launched in November 2021 is now just 17 days away from its target, and it actually took a picture of its target, at least the parent object of its target, and that is the asteroid Didymos. And in 17 days, this probe, DART, will crash head-on into Dimorphos, which is a natural satellite of the asteroid Didymos. We can actually travel to it. Dimorphos. Let's go to Dimorphos. All right. So here is that asteroid. Again, this is an asteroid orbiting another asteroid. That's kind of fun. It's a tiny, tiny asteroid, just a couple 100 feet across. And the DART spacecraft is actually planning to crash into this tiny asteroid. And the reason is that we are trying to test out if humanity could redirect an asteroid in case we spot one on a collision course with Earth. So again, the news update is that NASA's team said that we were finally able to see light reflecting off the asteroid Didymos after combining 243 images taken by DART's high-resolution imager called the Didymos Reconnaissance and Asteroid Camera for Optical Navigation, or DRACO. NASA loves those acronyms. DRACO's images will help the DART team optimize the software and navigation systems that are guiding the craft towards the asteroid system. While this image has confirmed that Didymos is in DART's view, the craft will be impacting Dimorphos, again the satellite asteroid. NASA is aiming to crash DART head-on into Dimorphos on September 26th, so stay tuned. We'll be tracking updates from that mission. Let's be clear, though, this is just an experiment. NASA says Didymos and Dimorphos do not pose a threat to Earth, and the energy transferred through DART's impact is low enough to prevent knocking them into an Earth-bound trajectory. We can zoom way out here. Oh, let's zoom back in. I just want to zoom. Oh, okay, too far zoomed. Zoom in there. All right. Just like that. So I just wanted to show you that this is an asteroid in the asteroid belt, very far away from Earth. It will not impact us, so don't worry. All right. The next news story is a bit of a happy news story. The team at the Giant Telescope, the Giant Magellan Telescope, that is, has announced that they've secured a $205 million investment for their upcoming gigantic optical telescope that will be constructed in Chile. The money is going towards a facility that will house the telescope at the Las Campanas Observatory high in Chile's Atacama Desert. When the telescope is complete, this is an artist rendering, the telescope will be 83 feet across. It will have 10 times the light collecting area and 4 times the spatial resolution of the Webb Space Telescope, according to release from the Giant Magellan Telescope Organization. For comparison, Webb's telescope is about 21 feet in diameter. The Atacama Desert is a popular place for ground-based observations because of its remoteness and altitude and clear skies. So according to the GMTO team, the telescope will scrutinize exoplanet atmospheres and early galaxies and will probe the nature and roles of dark matter and dark energy in the history of the universe. So a very exciting update from the team. Here's an scientific rendering of how high a resolution they expect when this telescope ends its construction. It is anticipated to receive its first light at the end of this decade. Currently, 6 of the telescope's 7 primary mirrors have been cast. So this is something exciting to look forward to. Perhaps in a future stream, a fully gray-bearded Patrick will tell you all about this Giant Magellan's telescope's first images. But in the meantime, luckily they have secured their funding. Funnily enough, if you're wondering how we can even use a telescope on the ground that's this good, well, it uses something called adaptive optics. Now, because our atmosphere is so full of gases, well, first of all, we love that because we can breathe, but second of all, it makes ground-based observation difficult. That's why we like to send telescopes into space, like Webb. But here on Earth, we can actually mitigate the effects of atmospheric distortion by using adaptive optics. And basically what astronomers do is they send a laser into space. They use a camera to observe how our atmosphere makes that laser's light wobble, and then using math, we reverse the wobble and sort of actually purposefully de-wobble the mirror at the telescope. So the mirrors actually have little actuators that can bend and flex them, and essentially negate is the best word, the effects of atmospheric distortion. It's a really cool technology that makes ground-based observations pretty much as good, if not better, than older space observations. So pretty incredible stuff. Ground-based telescopes are already using that technology, and this future telescope will be using that too. We've got Tara in the comments asking, I have to ask, have you seen a UFO? A real unidentified flying object? I am not sure. I'll tell you what, I do see my parrot Phoebe flying around overhead, but that is an object I can definitely identify, mostly due to the screeching. I tell you what, though, I did see the movie Nope recently, and you can receive a thumbs up recommendation from this space guy. That was a very fun and cool movie. I won't spoil it, but it does involve UFOs, but in a bit of a different way than you may have imagined. All right, just 2 more news stories, so this is your last chance to make any comments or questions. So let me know in the comments, but for now, let's check out this story. Here's another positive news story. We've got a lot of positive news this month. Isn't that great? And the news is that we have reestablished communications with the Voyager spacecraft. You may remember back in May or June, we announced, or I announced that NASA had announced that the Voyager 1 spacecraft, one of the first deep spacecrafts that we sent to space, we actually lost telemetry data from it. So we had issues with its data, and we were worried that we wouldn't be able to get any good science from it anymore. But now engineers with NASA have identified and solved the issue. And no, it wasn't aliens. The strange data was coming from Voyager 1's altitude articulation and control systems, which were responsible for maintaining the spacecraft's orientation as it hurtles through interstellar space at about 38,000 miles per hour. The garbled telemetry meant that Voyager 1 was communicating information about its location and orientation that didn't match up with its possible true location and orientation. But luckily, NASA identified that basically the Voyager probe was using the wrong computers. It basically was sending its telemetry data through a faulty computer aboard Voyager 1 instead of the non-faulty computer. So essentially, NASA engineers just redirected the data to be sent through the good computer, and it's working again. And this is really great. Voyager 1 was sent all the way back in the 1970s, and so far it has traveled 14 billion miles away from Earth. In fact, this is fun. Since we lost telemetry back in May, it has traveled over 100 million additional miles. So that's how quickly it's flying. So it's a small technical fix for humans, but one that ensures we can keep track of the Intrepid space probe as it continues its extraordinary journey into deep space. Emily says, is in the comments asking, can I get that technology put into my eyes instead of LASIK? Ooh, adaptive optics in your eyes. That'd be interesting. You know what? I'm gonna go ahead and place my bets now that I bet someday something crazy like that will be available. Although that would probably be a little more invasive than LASIK. I think LASIK is just the surface of the eye, but adaptive optics would be motors in the back of your eye that would kind of wobble your eyes to negate the effects of your eyesight. So I'm not sure you totally want that, but it's an interesting thought. Let's stick with LASIK for now. All right, we're going on to our final news story. One more comment, though, from Jerry. Jerry says, thanks for explaining the technology so we can all understand. It's very helpful. Absolutely, Jerry. And here's one final funny news tidbit, and this is pretty goofy, but there was a bit of not a hoax, so to speak, but something went viral that probably shouldn't have gone viral on the internet. Go figure, right? So if you're not an expert on the cosmos, it is very easy to confuse a view of a burning star with, for example, a slice of a piece of sausage. Well, this was tweeted actually a little over a month ago by Etienne Klein, who is actually a famous French physicist who recently trolled his followers on Twitter by posting a picture of a slice of chorizo and claiming it was the star Proxima Centauri as captured by the James Webb Space Telescope. So if you saw this posted on your parents' Facebook page, please let them know that this is a sausage, not a picture of a distant star. This tweet was liked and retweeted by over 20,000 people before the astronomer did reveal that this image was in fact a piece of Spanish smoked sausage and not the closest star to the sun. Easy mistake to make, though, to the untrained eye. Klein did apologize to those who fell for the joke, adding that he simply wanted to urge caution with images that seemed eloquent on their own. So double check your parents' Facebook posts, folks, because they could be a picture of sausage. All right, everyone. Well, that does wrap up my planned content for tonight's stream. And we will be wrapping up. So thank you all so much for watching. Get in your last second comments like Jeannie, who says, for those of us new to you, you mentioned monthly Monday streams. Can you tell us which Monday and time? Absolutely, Jeannie. That's a great question to ask at the end of the stream. We do stream monthly on the first Monday of the month. I know it's a Friday, but normally we do it on Monday. So next month's stream will be Monday, October 3rd at 6 p.m. Mark your calendars. We'll definitely have it that Monday. And if you've missed the past 85 live streams, that's right, we've done 85 streams up until now, then check those out on our YouTube channel, youtube.com/KCPlanetarium. You can subscribe to us over there, and you can find curated playlists of all of our past live streams. We've been streaming since March of 2020. Back then, we did 3 streams a week, as well as weekly deep dives into a bunch of different astronomy topics. So check those out. We've done a lot of amazing live streams. I built an International Space Station out of Legos. I flew to the moon in a VR headset. We took a deep dive into different space cultures from Africa and Asia and Native Americas and Europe and all sorts of amazing things. We did Hollywood astronomy, looking at the science of the movies and TV shows. So a bunch of awesome content to the past. But we're going to keep things moving into the future with our monthly streams. Thank you to everyone who has tuned in tonight. Thank you to Kate, who is watching from Fall River, Massachusetts. Is that MA? I hope so. Ooh, man, I'm glad I'm an astronomer, not a geographist. Chorizo is pronounced Charisse. Oh, okay, good to know. Thank you, Kate. Jerry says, thanks again for the evening. Thanks so much for tuning in, Jerry. I appreciate your excitement and support. Jeannie says, thank you. Casey says, no appearance of the bird today. What about the ukulele? Casey, I know it's been a while. We haven't had the ukulele in a spell. But maybe if Emily wants to bring Phoebe in here, then Phoebe can make a surprise appearance here at the end of our stream. But for now, we're going to start our outros. I have been your planetarium manager, Patrick Hess. Thank you so much for watching. And don't forget the planetarium opens back to the public next Saturday, the 17th. We've got an exciting lineup for the fall. We also have laser shows on the first Saturday of October. Thanks so much. We have a cameo appearance by Phoebe, as well as Emily's arm. Hello, Phoebe. Oh, and Emily. Thanks, Emily. What do you think, Phoebe? Say bye to everyone, Phoebe. Can you give me kisses? Oh, thank you. Good bird. How about scratch? Oh, scratch. Scratch. That was a scratch. A half a scratch. I'll take it. All right, everyone. Thank you so much for watching. Oh, thanks to our supporting sponsor, MRI Global, as well, and to all your continued support. I've been Patrick. Thanks so much for watching. We'll see you next month, and we're just gonna let Phoebe play us out with her cute tweets. What do you think, Phoebe? Scratch? Scratch? Almost. Scratch? Scratch? Yeah, that's a good scratch. Good bird. All right, everybody. See you next month. Bye. Ooh. Give me kisses. Give me kisses. Give me kisses. Give me kisses. She is over this. Give me kisses. Give me kisses. No more kisses. Oh, maybe a treat. Give me kisses. Give me kisses. Good bird. There we go. We're just gonna bribe her. Good bird. Scratch. Scratch. Good bird. All right, everybody. Thanks for tuning in.
Oh my
Bye-bye.
God,